And we'll start then. So hello everyone, my name's Dax. I'm one of the co-chairs of the Pod Climate Conference. Next up, we have Karan Gupta. He's an accomplished senior data scientist with a profound commitment to shaping the future of data-driven innovation. He holds a master's degree in information systems from New York University and a bachelor's in electrical engineering. Karan's journey has been to find impactful projects, from optimizing supply chains using predictive analytics to crafting advanced ML tools. He's leveraged Python, big data tools, and data visualization for tangible outcomes. His passion for sustainability extends to various works, evident in projects that reduce waste and carbon emissions. The blend of technical expertise and a drive for positive change, Karan continues to strive to elevate industries and contribute to better worlds. Please welcome Karan Gupta.
Thank you so much, Daksh. And hi, everyone. So my name is Karan, and I'll start with the presentation. Please give me a moment. Sorry. So can you see my screen?
Okay, Karan.
All right, so everyone, so the title of my presentation is Unleashing the Power of Predictive Analytics from Data to Insights. Like how we can use the power, like how we can use the predictive analytics to for harnessing the data for a greener tomorrow. And so this is what I want to discuss today. Like first I'll briefly go through the introduction. Then what is the business problem that we were that we were facing? Okay, so what was the solution that we proposed, and what was the data that we used and the methodology, and then how we compare the model. So whatever the predictive analytics model that we build, so how we evaluate the model performance, and the next I'll talk about like the achievements in climate sustainability that we achieved using the predictive analytics, and then I'll conclude, and then I'll open it, and then we can go for the question and answers. So let's talk about the introduction. So what are the common problems and what the businesses are facing? So first one is the unsystematic prediction of residential project delivery. So let's say we are working in a solar industry, and one of the most common challenge that we face is, okay, so when our solar panel will be installed, or so this was one of the key challenge. So, and many of the businesses rely on the intuitions, like they don't have are using the proper predictive models, or they might be using the simple linear projections when they're planning for the future projects. And this lack of systematic prediction method, so this leads to the inconsistencies, last minute changes, and it often leads to the financial losses. Second challenge that is very prominent is about the supply chain and the operations. So because of course, like most of the companies have the dependence on the historical data, and using that, they try to project for the future. Like, okay, so what should be the future look like? So as a result, what happens is sometimes the companies are not prepared for the sudden shift in the demands, and as a result, so they might face like sometimes overstaffing or understaffing at most of the locations, and sometimes they not for the overstaffing, not for the staffing, as well as for the resources, because sometimes they are they have the abundance of like resources available, let's say at a particular location where they don't require much, and at some of the locations they are under they are understood, they don't have the sufficient like the things that they need. So this problem actually this create a strain. This is an immense strain on the overall supply chain and the operations. And then so we need to have an evolution. So to remain competitive and efficient in this business, so we need to adopt some changes that can actually help us to deal with these challenges. So what was the problem that we were facing? Yeah, so one was so as I told you, so we don't have the systematic ability to predict when the projects will be delivered, and the lack of this ability was resulting in a couple of problems. Like one was the problem with the inventory or the planning team, who manages the inventory. So because their approach relies on the past data, so and because they were relying on the past data and they were using the past data, they were projecting the future. So which has ultimately led to the shortages in most of the locations, even though the supply chain was working fine. There was a sufficient supply overall in the network. Second one was the operations team. Operations team was relying on the outdated method like the Excel models. So, like to plan the staffing, and because of that, because they were kind of outdated models, they actually like went into a problem wherein at most of the locations they were they were understaffed, and at most of the locations they were overstaffed with the people. And third one is the finance team, because we don't have the proper projections, and the finance team was not able to like forecast or have the proper revenue recognition, like how our revenue will look like. Let's say, okay, if we have to make a projection for, let's say, the 3 months, or let's say in the next 5 months. So these were the problems that the businesses were facing. And then what we did is, so we built an algorithm to predict. So that predicts the estimated installation date. Okay, so when your residential, okay, so when your project will be delivered, and yeah, I mean, basically this project was, I mean, this model, I mean, this algorithm was built for those projects that doesn't have the installation date. Yeah, so this is what we built. So basically the algorithm. So when you give us the data, so using that algorithm, so we can predict, okay, so this will be the tentative date when your model will be, sorry, when your project will be installed. So this is the algorithm that we built. So if I talk about the data methodology, what was the data and how does the methodology looks like? Because so in a business, this is one of the most common problem wherein we face the problem of like clean data or the data quality. And what I mean to say is like we don't have a clean data, like, right? I mean, so whatever we are looking for, we might not able to get a good number of data sets, I mean, on which we can train the model, or which that we can use so as to have a good like projections or the prediction for the future. So we have like as I work in SunPower, so we use like 12 months of data, and like because we use Salesforce, so most of the data was there. So we use that data. And we split the data into the two parts. So first part looks like the data that have the installation date. So basically one set of the data, one part of the data has is like, okay, so these were the customers and these were their install dates. So basically the customers that already have their uh, projects installed. So that's why we split it into two. So one part is the customer that have the install date. I mean, their projects were delivered, and the other part of the data looks like that for the customer that doesn't have the install date. So, and what we have to do is, so we will train a model on the part one, because we have the install date there, and and we'll evaluate the model there, and then we'll use that model over the part two so that we can have the predictions for those that doesn't have the install dates. And we omit basically 6 months of data because there were a couple of projects which were introduced. I mean, so we excluded the past 6 months of data while training the model. The reason is because it has a lot of uncensored data, maybe a couple of projects that were like not put into the place. So we don't want to keep them. So we just look around for the like past one year of the data, like excluding this one. And if you go like one year beyond, so six months. So that's how we selected our data, and we collected the data from the different sources, what different sources we have in the company. So that's how we basically manage the data, like try to clean it up, and then make some modifications, and then we were able to put in the place. And for the methodology, so we tried with a couple of methods. Of course, we start with the baseline model, let's say the logistic regression, and then we use a couple of models to compare like which one is giving us the good results. And at the end, we come up with a light GPA model because it was giving us the best performance. And so we went ahead with the light GPM, and that's how we selected our model. So now the next part is like how we evaluate the model. So this is the most crucial step of like how we can evaluate. So one of the part is, so while training the model, so we follow this process of cross validation. So what does the cross validation do is, so we followed a five-fold cross validation. So what it does is, so let's say it splits the data into the 5 parts, and what it will do is it will train the model on, let's say, first 4 parts, and then it will test on the last part, so like on the fifth part. So and then in the next iteration, so let's say it will train the model, let's say, on the last 4 parts, but it will test the model, like it will test the model performance on the first part. So the reason of using the cross validation is let's say in future, let's say if we see if you have a data that we have not unseen, so how we can tell like our model is performing good or not. So this was the only reason of using the cross validation, and yeah, and this is the process. I mean, this is the part that we use. This is basically the method that we use to evaluate our model. And how we were evaluating the model is using the absolute error. So absolute error is basically the difference of the actual days minus the predicted days. So predicted days is the days that we predict, that our model is predicting for a like for a given data point or a given data set, and actual days is the days like that we have already in the system. So that's how we evaluate the model. And I will also show you and so basically when we have the error, I'll show you like the distribution, like the error distribution matrix, which is on the next. I'll show you that. So basically, so while doing the cross validation, so as you're seeing, okay, so let's say in the iteration one, let's say the error is x1. In the iteration two, let's say the error is x2, and in the 5 iterations, right? So we have error x1 till x5. So basically, we'll select that iteration wherein we are getting the less error, and that's how we finally selected the model. Like we have the right GBM. Okay, so but when you start training a model, so we have to and since you're using the cross validation, so you have to see like, okay, so which part of the data set is giving you the good results. Although everyone is performing well, but we selected the one that is giving us the best. So that's how we finally selected the model, um, using the absolute error, or like I mean the median absolute error. So that's how that is the model evaluation and the model selection part. And I'll walk you through a couple of observations that we have. So basically each project, so let's say when we take a project, let's say if a customer come to us, so the project is, so I mean, it's not like customer comes to us and will tell you, I mean, it's not like customer is coming and will, so so let's say if any of the new project is coming up, so it has to go through a series of steps. Let's say milestone one, milestone two, milestone three, four, and five. So milestone is one basically when a customer comes to us, and then let's say the team will go and they'll do all the inspection, and then it has to go through a couple of steps. It's a very long process because you have to take the approvals, and then it will go, and your solar panel, once you have the solar panel, it will connect to your grid. So that like let's say, because in most of the cases you can sell your energy to the grid as well. So there are a couple of milestones that you have to follow. So milestone one, the first is the milestone one. Then you go to the milestone two, three, four, and five. So if you see in this table, um, so when you're at the milestone one, if you see okay, so in the milestone one, two, and three, because these are the initial steps. So if you see in the first part, which is the all section, the median error is around 28 days. But as you gradually move forward, so median error tends to decrease. So which is a good sign, right? I mean, because as you're going closer to the installation, the error should decrease because the number of days should decrease, right? As we are going near to the installation date. So this is the distribution matrix of for like across each milestone, and then we also have two other sections, which is the predictions which were made earlier than the actual and the predictions which were made later than the actual. So what it means is, let's say we have the actual date, but our model is predicting like a little earlier. And then the other section we have like prediction, which is later. So this is how we went on and we evaluate our model. And because the median error is keep on decreasing as we are going forward in the milestones, so this is a good sign that yes, our model is that yes, the model will work better. And to further evaluate our model, so we did something called as the backtesting. So in the backtesting, so you go back, so you have the model, but you go back and then you try to see, okay, if your model is working fine or not. So just to make sure. So we did we did for the 4 quarters, like starting from the last quarter of 21. And so I mean, uh, so this is the result till the last year of the quarter three. And if you see like the precision and recall, they remains almost consistent. So which is a good, which tells us that yes, the model is working fine. And if you go to the accuracy section, so accuracy is also like it's also above one. So it basically tells us like for example, if I talk about the accuracy 1.12, so it means that the prediction for the quarterly inventory are 12% more than the actual needed. So accuracy tells us like if it is 1.07, it means that we would need 7% more inventory than it is actually needed. So this is what it means. So because our results for precision and recall are very consistent, so it means that we can rely on accuracy, and this is what is reflected in our results. And so since we are able to automate this whole method, and it was put in place, so we achieved a couple, we achieved good results, like how we contribute to the environment. So first one, if I talk about the emission, the emission reduction. So in the Q1 of 2023, so we were able to offset because we were strategically able to implement solar panels using the predictive methods, which were not used to be, which doesn't used to exist before. So, but since we introduced this method, so we were able to offset this in Q1, around 7.4 million pounds of CO2. In Q2, it was 15 million. In Q3, I mean, we have to make the calculation, but it was so when it did the calculations, so it was at that time 1.7, but yeah, of course, it was the numbers would be very up. So we were able to because since we were able to place the systems on time, so this much is the amount of CO2 that we were able to offset. Second one is the consumer confidence, because we were able to install the panels in time for the customers. So which actually gained the consumer confidence, and the cancellation rate, which is one of the major thing in every industry. If you are in this industry, so the cancellation rates for each quarter was actually it actually decreased, so which is a good sign for the business as well. Third one is a reduced energy cost. On an average, a customer who has the system in place on time is able to save around $1,500 per year in electricity costs, which is another remarkable achievement for us. Fourth one is the investment in the funding. So I mean, because of the work that we have done, so we were able to attract the new investors into the business, and as a result, the business was able to achieve $1 billion of investment from two major investors. That could actually help us to extend the loan business that we have, because the company operates in the three parts of the business. One is the loan, lease, and the cash. And because of the work that we've done, so we were able to achieve the funding to extend the loan business, which was around $1 billion. And yes, and the fifth one is about the resource optimization, because we have the streamline of because by accurately predicting inventory requirements, so we have optimized the supply chain and allocated human resources effectively. So we have the enhanced inventory management. So we have boosted our supply chain efficiency, and of course we have optimized the human resource allocation. So this is what we have we were able to contribute, and yes, and that's it. And finally conclude about it's so predictive analytics will complement. So it's not about they are mutually exclusive. Predictive analytics and sustainability are not mutually exclusive, rather they complement each other. And predictive analytics, of course, it provides us the tools to efficiently forecast and optimize resources, as we have seen in a result that I showed you. Second one is we have the enhanced environmental impact. Let's say because we were able to optimize our supply chain, our inventory. So we were able to and we were able to place the system on time. So yeah, of course. So it helps us there as well. Third one is revolutionizing industries. So with predictive analytics, the industries can reduce costs and increase profits by optimizing resources, as we have done. So businesses can adopt greener practices, not just as a marketing strategies, but as a genuine move towards sustainable future. And third one is the stakeholders can gain clarity on sustainable driven initiatives, ensuring the continued investment and the trust. So yeah, so at the end, I would like to say of course, the integration of predictive analytics in sustainability initiative promises a future where businesses thrive without compromising the health of our planet. So yeah, so this is all about the presentation. And if you have any questions, I'll be happy to take it and I can discuss it with you.
Thanks so much, Karan. We do have a couple of questions. First of all, someone to ask, do you foresee future improvements in your predictive analytics work to drive more efficiency? And are there any blockers to this?
Yeah, of course. We do see the future improvements because so what we used to do is so every quarter we used to retrain our model with a new data set, so that let's say if let's say if anything new, let's say sometimes pops up, which you called as a seasonality, so it should take care of that. The quarterly retraining is important, and yeah, the blocker is always about the seasonality, because let's say for some of the quarters, let's say certain product is very popular, let's say in the next quarter, some other product becomes very popular. So we do have to take care of the seasonality as well. So that is one of the main blocker, which we always face, the seasonality.
It's great to hear. Also, I know you had mentioned briefly about your carbon dioxide offset metrics. As you're starting a project right now, and you're in early phases, but what do you guys project this to grow to, this market for offsets? And this will be like a business line separately at Suncor.
Yeah.
So what do you project the market to grow to? Offset is like a substantial market in its own, or could you shine light on that?
Yeah, so basically this is what I calculated for the work that we have done. But yeah, of course, if because this is just for one company, but of course, if you combine all, the numbers will be like huge. So let's say in the quarter one, let's say for our, it was, let's say, around 7.7 million pounds. But let's say if you combine all, so it might be around 100 million pounds for a quarter. Yeah, for a quarter. So and this number will gradually increase. But right now, the problem that we're facing is because of the higher interest rates. Some people are like little hesitant to go and buy these things, but of course, the things will gradually improve and the numbers will keep on increasing.
Well, I think that's all for today. Thank you very much again, Karan, for joining us. It was great hearing from you. Anyone can reach out to you after this conference for your questions and answers. Now we have